Hello students, this is Mrs. Jones, and we are back doing more Trig. Trig is fun, Trig is easy, Trig is very meaningful to our careers. We're going to talk about today something that's called inverse trig. All of the things that we've done so far are finding missing sides of a triangle. Inverse trig is used to find angles. So we're going to do a couple examples here. I've eliminated this part of it. I don't want to talk about that today. I just want to talk about finding the angle. So let's look at this one because the first one has fractions in it, and fractions make me nervous. So here's our triangle, okay? And we want to find this missing angle piece, okay? What we're going to look at is we're given information about the hypotenuse and we're given information about the adjacent. This piece is the opposite, but we're not given any, we don't know the value of that. So we know the value of the adjacent and the hypotenuse. Do you guys remember which trig function is adjacent and hypotenuse? That's right, it's cosine. So we're going to say the cosine of our angle, I know we don't know our angle, but we're just going to put m there, is the adjacent over the hypotenuse, right? That's our formula. We set this up, and then now we know we're trying to find the angle, so as far as what we put into our calculator, we're going to use the inverse cosine. So in our calculator, we're going to put the inverse cosine of 31.2 divided by 41.7. So let me talk to you a little bit about how you do that in your calculator. Most calculators, most Texas Instrument, if you have a Casio calculator, throw it away. Throw it away and get a Texas Instrument. That's a biased opinion. I shouldn't be saying that, but the Texas Instrument calculators are a lot easier to use in my opinion. But to put this in a calculator, you would hit the second key. It's normally like yellow, or it's a different color, maybe orange. And then because we're using cosine, we're going to hit the cosine. And on your calculator, it should come up as COS with a little -1. And then you're going to put in your 31.2 divided by 41.7. You're going to close the parentheses and you're going to hit equals. What the inverse cosine does is it works the trig function backwards. So it will tell us the angle, and that the angle is 41.565, and this is degrees. Notice I've been doing everything in 3 decimal places. That's the standard that I want you to stick with. All right? Let's do another one. Yeah, we'll go over here. So right off the bat, I would turn these fractions into decimals so that I didn't have to worry about them anymore. And if this is my reference angle, I labeled my sides. This is my hypotenuse side, and again, same type of problem, that's my adjacent side. So because we're given adjacent and hypotenuse, that's how you know you're going to use cosine. So I would set the cosine function up first. Cosine is the adjacent over the hypotenuse. I would set it up, and then I would say to myself, but I'm trying to find the angle. So since I'm trying to find the angle, I'm going to use the inverse cosine, and this is what I'm going to put into my calculator. So again, in the calculator, you hit the second key, and then cosine, and it should come up with the -1. And you put the rest in, and it's telling me that my measurement of my angle is 60 degrees. Yes? All right, let's do one more example, because these both were cosine, and I don't want you to get the idea that everything's cosine. This problem, and I apologize that the top of the triangle cut off, all right? But if this is our reference angle, then the 2 11/16 would be the opposite, and the 3 1/16 would be the hypotenuse. Again, fractions, I hate them because not everybody knows how to put a fraction in a calculator correctly. So I advise everybody to change them into decimals. How you do that, you just do 11 divided by 16, and it'll give you the decimal part. Do the same thing with the 1/16. And then it takes all the fraction worry out of the problem. So since we are given hypotenuse and opposite, what trig function is opposite in hypotenuse? That is sine. So we set up, I like to set up the formula first. It's the opposite over the hypotenuse. And then I go, oh, wait a minute, I'm trying to find the angle, so that means that I'm going to use the inverse sign, and then I'm going to put the rest of the problem in there and divide it. So in my calculator, I hit the second key, and then sine, and it should make that little -1 appear. And it's telling me that my angle measurement is 61.348 degrees. Okay, again, like you always ask yourself, does it seem like it's correct? Yeah, that kind of looks like, if it's drawn to scale, we can say, yeah, that looks like about 61 degrees. You're looking for things that are alarmingly wrong, because if you get them wrong, most likely they're going to be really wrong, and you'll be able to tell that right away. So let's look at one more example. Okay, it says find the angle of the taper on the steel bar shown if it's equal to twice m. So what the actual question is asking is for the whole angle. But what we're going to do is we're going to look at just the triangle, just the little right triangle. And then we're going to double it. So this is m. The 15 is going this way, and the 13.5 is actually there in the middle. Okay? So if that's our reference angle with the m, this is the hypotenuse, this is the adjacent, right? Adjacent and hypotenuse means that we're using cosine again. We go cosine of our angle is the adjacent over the hypotenuse. And in our mind, we're going to go, hey, I'm trying to find the angle, so that would mean I use the inverse cosine of 13.5 over 15. So if I do that, that says that my angle M is 25.842 degrees. Now we're going to keep going further here because that's just one side of that taper. We need the whole side. So we would double this, right, to get the whole thing. $51.684 degrees for our whole taper. Now, I want you to notice, we'll just extend this a little bit. This is kind of like a extra thing to do. Look at that, that says round to the nearest minute. So technically our decimal answer is wrong. We've got to remember, how do we take 51, go back a couple lessons in your brain, how do you take this decimal and turn it into degrees and minutes? Remember, you chop off the 51 and you take just the decimal times 60. Do you remember doing that? And because it's asking for the nearest minute, our answer, 41.04, we would just round it to 41 and we would be done. Now, if it was asking for nearest second, we would do the multiplication by 60 again. All right, but our main focus today was making sure that we know how to do the inverse trig, and that the inverse trig is used to find missing angles of a right triangle. There is a Google quiz for this assignment. Make sure you hit submit at the end. Make sure you hit turn in the upper right hand corner of the Google assignment. And if you have any trouble, please feel free to email me at cjones@ictc.edu. I hope you guys are having a great day, and I hope to see you soon. All right, bye.